Hello, everyone, and welcome. My name is Beth Capellas, and I'm the Sales and Support Manager here at Triangle Microworks. I'd like to welcome everyone to our latest webinar, Charting a Course to a Digital Substation, How to Integrate IEC 62850 in Your Existing Solutions. I'd like to mention that this is a three-part series. Today's webinar is part one, an introduction and comparison to DNP3 and IEC 62850. We'll talk a little bit about part 2 and 3 later in the webinar. However, you can always find out more information and details on our website at trianglemicroworks.com under the training tab. Before we get started, I'd like to go over some housekeeping items while everyone is still joining. The webinar is scheduled to be 1 hour long. We have a lot of material to cover today, but we will try to take at least 2 breaks to answer questions. The audience is on mute, so please submit your questions online using the webinar toolbar under the section titled Questions. You can submit these questions as soon as you have them. Please don't wait until the end. We will begin answering questions online as we have several engineers monitoring the questions and responding to them directly. We're also happy to stay on after the webinar is over and answer as many questions as we can. So with that, I'd like to introduce the folks behind the scenes answering those questions. Today we have with us Greg Godolewski, who's our engineering manager here at Triangle Microworks. And we also have Dave Kuchenauer, our lead developer for Distributed Test Manager, also known as DTM, which is one of the tools that you'll be seeing here today. Next, I'd like to introduce our speakers. First, we have Christoph Brunner, President of IT for Power. Christoph is a well-known utility industry professional and 62850 expert with over 30 years of industry experience. Christoph has been involved in the development of the standard since the beginning. He's convener of Working Group 10 and member of Working Group 17, 18, and 19 of IEC TC57. He's an IEEE fellow and a member of several IEEE working groups, as well as a member of the PSRC Main Committee and Subcommittee H. Next, we have Jackson Moore, Application Engineer at Triangle Microworks. Jackson received Bachelor's of Science degrees in both electrical engineering and computer engineering from North Carolina State University and has a background in power system engineering. Prior to joining Triangle Microworks, Jackson spent 5 years as a microgrid system engineer, where he designed and developed load management control systems for multi-source microgrids, ranging anywhere from 1 megawatt to 30 megawatts. In his current role of application engineer, Jackson serves as a bridge between our customers and our development team, seeking to understand and solve unique and complex challenges our clients face. So now that you know everyone here, I'd like to give you a little bit of background on Triangle Microworks. We were established in 1994 and have over 28 years of communication protocol experience. We're headquartered in Raleigh, North Carolina, and have customers in over 70 countries. We work mostly with equipment manufacturers, electric utilities, and system integrators. The products we offer all support the standard SCADA protocols and fall into 3 categories. First category is source code libraries. We license source code directly to manufacturers for use in their devices and systems. This allows for a much faster time to market and greatly reduces their costs and development time. Licensing a source code library also includes support for your implementation and any issues that may arise in the field. We also provide testing tools supporting these libraries and protocols. These tools are used for communication testing in the lab or the field. They're designed to troubleshoot, simulate, and automate testing for both a single device or a complete substation. Lastly, we also provide a SCADA data gateway supported on both Linux and Windows for protocol translation and data concentration with standard SCADA protocols, as well as OPC. It's available as software only or pre-installed as hardware. We are also heavily involved in the standard committees that support SCADA protocols like UCA Group for 62850 and DNP User Group and Technical Committees. Through our participation, we help define the protocols, stay up to date on the changes taking place, and ultimately provide feedback based on our customers' needs as the protocols continue to evolve. So with that, I would like to go ahead and hand it over to Christoph, who's going to kick off the webinar for us. So Christoph, I'm going to go ahead and make you presenter.
Thank you, Beth. Welcome everybody from my side.
Okay, and you should have the screen now.
Yes. Okay, I hope you see the screen. So in this introduction of our first webinar of this 3-webinar series, I would like to introduce IEC 61850. As many of you are familiar with DNP3 or other SCADA protocols, I will use DNP3 as a starting point and explain what is similar in IEC 61850. The graphic here shows a substation like we know it for a long time. We have what we call station level devices like the gateway and the local HMI, and we have microprocessor based bay level devices like protection relays. Communication between the devices and the HMI is using SCADA protocols. The interface to the process is wired. Also wired is typically the interaction signal flow that is required between the devices to implement protection schemes. In this classical world, information that a device could provide was declared through a point list. The SCADA gateway probably or may remap some of those points for the communication to the control center. Here we see one of these classical point lists. When we talk about design, we mainly had two things that needed to be done in this classical world. We had to assign communication addresses for the different devices for the SCADA protocols. With regard to the applications, we more or less had to draw wire diagrams, wires exchange between the different equipment to implement the applications. Those wires were really then also physical wires with binary signals or analog signals. In the second part of this, in the second webinar of this series, we will see how the design will be done with 61850. But for today, let's focus on the protocol. And we will start now the introduction on 61850 on the protocol level. Again, starting from what we know from DNP3. DNP3 is used from control center through data concentrators down to devices. Within a substation, it's typically used for what we call sometimes vertical communication between IEDs and the gateway local HMI. DNP3 provides control of process equipment and event-driven data acquisition with quality flags. Similar functionality, like what we just discussed on DNP3, is supported in IEC 61850 by what we call there the client-server communication using MMS. But IEC 61850 adds two protocols on top of that MMS communication, or in addition to that MMS communication, which is the vertical communication. 61850 adds two protocols that are typically used for communication between the devices and that are a key for the digital substation. One of them is what we know as GOOSE, or Generic Object-Oriented System Event. The other one is the transmission of sampled values. We will introduce those two communication concepts later in this introduction. Getting back, as already mentioned, a lot of the functionality that we have in DNP, we also find in 61850. So I have a lot of functionality that is equivalent between these two protocols. But in some cases, we use different terminology. That's why I try to compare them a little bit here to help you find the related things that you know from DNP in 61850. So while 61850 uses the terminology client-server communication for the vertical communication, in DNP3, we typically talk about master outstation communication. But also in DNP3, we have the possibility that multiple masters can access the same outstation, or that the same outstation can be, or that outstation can also be accessed by multiple masters. When we talk about the communication services in DNP3, we typically call it function codes, what is identifying the purpose of a message. And we have messages like read, write, select, or operate. In IEC 61850, we call those services. Service names identify the purpose of the message. But we have similar services, like we have a get data, which corresponds to the read. We have a set data service. We have select with value, which is the select service, and we have operate. So the services we have are very similar. They have just a little bit different names, and we call them services. When we talk about information in DNP3, the information is organized in points, like in all the SCADA protocols, and the information is identified with a point index number. In 61850, we call the information data object, and the identification of a data object is with a string. We'll explain that on this next slide. So somewhere here, we have a 61850 device. The data model is hierarchical. Somewhere in here, we have a data object. In this case, the data object is the position, and the identification of that point would be through a hierarchical path created down from the hierarchy. Now, what is the hierarchy? On top of the data objects, we have logical nodes. In this example, we have a logical node called XCBR or circuit breaker. We will talk about logical nodes a little bit later. And on top of that, we have logical devices. So all that's what we find within an IED. Beyond the data object, we have then the data attributes. That's where we have the values. So looking at the naming again, we not only can identify this data point, but we also can identify the other elements. So as an example, we can identify a logical node. We also can identify the logical device. And as you have seen, the data point itself is really identified through a hierarchical path. Okay, now again, some more common characteristics that we have between DNP3 and IEC 61850. Both protocols have quality indication to indicate the quality of the data. DNP3 has various flags indicating if the data is valid and reasons why it's not. 61850 in a similar way, but it has an explicit validity flag and additional flags indicating the reasons why a value could not be valid. With regard to timestamping, both protocols use timestamps. Both require the timestamp to be in UTC, but also in both protocols, it's possible to indicate local time zone. With regard to control, again, both protocols support direct operate and select before operate. One of the differences that in the IEC 61850, the status information is directly associated to the control point. So it's the same data object where we do the control and where we get the status back. In SCADA protocols like DNP3, we typically have two independent points, a binary input for the status information and a binary output for the control point where we do the control. With regard to event-based communication, again, both protocols support event-based communication. In DNP3, this is called report by exception, which is supported through the use of unsolicited messaging and event class polling. In 61850, the similar functionality is called reporting. Similar to the unsolicited communication, once reporting is enabled, the server will send events without a client request. DNP organizes the event data into class 1, 2, and 3. In IEC 61850, the event data is organized through the concept of a data set, which defines the data scope. And as well, we have a control block that defines various constraints for the event-driven communication in 61850. Most characteristics of event-based communication in DNP3 are predefined and documented through the DNP3 XML device profile. In IEC 61850, those are attributes of the report control block, and in some cases they can be changed even in a live system. Both protocols support general interrogation, both support cyclic reporting, both protocols support buffering of events. IEC 61850 has as well a non-buffered reporting model, while DNP3 has a concept of reporting only the most recent change, where we don't have exactly the similar concept in 61850. There we use more the unbuffered reporting when we don't need the events. Okay, now let's have a closer look on how that reporting works in IEC 61850. And in the first step, I would like to introduce the IEC 61850 dataset. A dataset is basically can be seen as a reference to a couple of data points or data objects that we find in our system. So in this example, we created just one data set where we can find all the positions from the different switches we find in that feeder. When we now want to configure a report where whenever one of these switches changes, we will get a message with an updated position. So whenever we want to do that, we now have our data set. And now we need what we call a report control block. And the report control block on one side points to our data set. So with that, we know the behavior described in this report control block for event-based communication is applied to all these data objects. And then we also can configure additional information, the behavior mainly, like the trigger options, under what conditions should we send a new event, as well as the identifier of the message. And based on that, we will then have report messages going out. Now, how does the mechanism look? So we have our server and our client. The client may set up and he has to enable the report. And once the report is enabled, and whenever we have an event happening, a report message will be sent from the server to the client. And this continues with each event, a new report will be sent. Now, what is an event in IEC 61850? An event can be a data change. In that case, the data that has changed will be packed into the message and sent as a report. But we also consider integrity period expired. So what we are using for cyclic reporting, that's another kind of an event, or also general interrogation. If we issue a general interrogation, then we also will send a report. While for data change, only the information that has really changed will be put in the message. Integrity period and general interrogation will always report the complete data set that is associated. As already mentioned, we have both buffered and unbuffered reports. With buffered reports, events are buffered for retransmission on request following a loss of communication. With unbuffered reports, events may be lost during communication interruption. This retransmission, when we reconnect, the client can request to continue sending the events that he didn't receive, but he can also tell to purge the buffer and just send new events. So much about reporting. Now, as I mentioned before, IEC 61850 added two protocols to the MMS, which is the vertical communication, and one of this is the GOOSE. GOOSE basically is intended as communication between devices to implement protection and control schemes and more or less replace physical wires that we had in a classical substation. We had binary outputs where we routed signals. Then we went on binary inputs from the other relays, as an example, blocking signals. Now the communication mechanism called GOOSE, or Generic Object Oriented System Event, can basically replace these wires. How does this work? So again, let's assume we have our data set with all the positions. At a certain moment, these positions have specific value. We call that a state. And based on that, the message is sent over the network with the state in, and we also have a state number that changes whenever something changes. A subscriber that is listening is not necessarily required to receive all the data. He just, in this case, needs these two information. So when he receives the message, he can check these values, store them locally, and with that, he knows now more or less the value there. Now, if something changes, so let's assume that data changes from off to on, that means we now have a new state, which will increase the state number here, and the new value will be in. And again, that new message is published out. The subscriber notices that there is a new state number, and as a consequence, he can recheck the information he needs. He will identify that this does not change, but then he can look and he will see that this value has changed. So he always needs to read the values he is interested, and then he can identify what has changed. Now that's the basic concept. In order to make that reliable about our Ethernet technology, we introduce certain repetitions. As a starting point, when we don't have a change of the state, instead of just sending that message once, that message will be repeated with a predetermined time, which is typically configurable, until the next event. So as an example, we will have every 1 second a repetition of the same frame. This can be used by the subscriber to detect that the publisher is still alive and still publishing messages. So the information he has is still valid. Now next, when we have an event, that means when an information changes, the publisher will immediately send out a new message independent of this timing, will immediately send a new message, and then it will repeat the messages with a much higher frequency in order to care for communication loss and still fulfilling timing requirements. But once having repeated it fast, there's a process in that it slows down, and after a while we will get back to the normal maximum repetition time that we have in the steady state when nothing is going on. So with that, on one side we ensure a fast reaction when something changes, but then we also ensure the supervision of the publisher without using too much bandwidth on the network. The content for GOOSE is configured similar to the reporting. We have as well the data set. Instead of having a report control block, we have a GOOSE control block. But besides that, everything is more or less the same. Now let's have a look at the sampled values. Sampled values are typically used when we introduce what we mostly call merging units, which is an analog digital conversion directly at the source where we have our current and voltage sensors. In that case, instead of having an analog signal going to the devices that need to process this, and each of these devices having its own analog digital conversion, we only need one analog digital conversion, and then we send out a stream of sampled values over the network. The mechanism behind works as follows. We have at a certain moment, we sample the values and they get an identifier. So when we have different sources, they get an identifier when they have been sampled. And then they can get delayed over the communication because there may be some jitter in the communication delay. The subscriber on his side just needs to wait until he gets a set of samples with the same number, and then he knows that those have been taken at the same time, so they are correlated to each other, and he can use them for his algorithmic processing. Of course, the sampling here needs to be time synchronized. That's why we know then that those have all been taken at the same time. Okay, so much about the protocol level, DNP3 and IEC 61850. Now let's compare them at more the functional level. At functional level, DNP3 defines various types for the data points. 61850 has a similar concept, but there we call it common data classes. Common data classes in 61850, however, do not only include operational process information, like typically in the SCADA protocols, but here we also include other attributes like the scale factor, deadbands, control output pulse configuration, and so on. Additionally, some of our common data classes can be hierarchical structures. As an example, there is one CDC defined that combines all the three phase measured values into one type. As already mentioned earlier, in 61850, we call the data points data object. And that's one of the differences. In 61850, we have standardized the names of these data objects, and we have given semantic meanings to the data objects. Data objects that belong to the same functional element, they are grouped in logical nodes. So the next slide tries to compare that. So what we see above is a table that shows an extract from a DNP3 device. So somewhere we need to know that in this device, the point, and in this case it's binary input point with the number 6, is associated to the breaker open contact. The point with the index number 7 is associated to the breaker close contact. In IEC 61850, this same information we will find in a standardized data object called POS, and this will be placed in a standardized logical node called XCBR. So we know when we have to search for a position that we always have to look at position of a breaker into the XCBR. We need to look for the data object POS for position, and there the status value stval will indicate the position. In the second part of this webinar, we will see that in a live demonstration given by Jackson. So when we look at logical nodes again, as mentioned in 61850, the logical node is one of the key elements of the data model, and it's a container for function-related data. We have here an example of a switch. We see different data objects, the type, which is a reference to the common data class. We also see indications that information, some of them is mandatory, other ones is optional. We also support the possibility to extend the model with vendor or user specific data, but we will not have time to go in all these details. Data objects and data attributes, as mentioned, data objects are based on common data classes that are as well standardized, in this case, a double point control. In a common data class, we have attributes like the real operational attributes, status value, quality, timestamp. But we might also find configuration attributes like pulse configuration. We can configure the output pulse, the control model. If it's a controllable point, are we supporting direct control or control with select before operate? If you have select before operate, configuration parameters like timeout. So all this information we will find in the same data object. Of course, typically for reporting of the events, we are limiting it to the operational part, but the other information is as well available. We also support substitution or blocking of information. Okay, the last point I would like to mention is the device profile or the corresponding element in 61850. So a DNP3 device supports a device profile which describes capabilities of a device, including a point list. In IEC 61850, in a similar way, we require that the device provides a PICS, protocol implementation conformance statement, and MICS, model implementation conformance statement. So PICS corresponds to the capabilities, the MICS to the point list, which is in this case the 61850 data model. DNP3 device profile exists as an XML device profile. In principle, they are required to be provided in XML. In a similar way, in IEC 61850, as part of our system configuration language, or SCL, we support the ICD file, or which is called ID device capability description. How does this look? An ICD file, we basically see here, it's an extract, and that will be a topic that we discuss further in the second webinar of this series. But we have a service section which provides the capabilities, and then we have a data model section which provides our information model, the data model, and we have a template section where we have the data types that we are using in that device. Now, before I hand over to Jackson, I would like to summarize again and explain a little bit how GOOSE is replacing wires. So when we talk about an application, we may have in 6.1, we may have multiple devices. The yellow boxes here are devices. In the devices, we have data, which is grouped in logical nodes in 61850. And for some applications, some of this information is required in other devices. So we may have, as an example, a signal from here required to be used for this functionality in this other device. So we may have all kinds of signals flowing between the devices. In a conventional world, these signals that go out here would be mapped on physical outputs. They would be packed in a mass message, and then would then go on physical inputs into the devices that have to use these signals. In 61850, we basically create messages behind. We assume virtual outputs instead of physical outputs. We pack them in a GOOSE message, and we send over the GOOSE message. And then instead of having physical inputs, we have now virtual inputs that we wire to our applications. And with that, I think before we go to the demo, Bess, we have some question and answer session, correct?
Yep, we do have a couple of questions that have been coming in and we've been answering online. The one question I would like to put out there for you, Christoph, let me go ahead and read it off. 61850 appears to be an IoT application, pub sub model. Is it using UDP under the hood or TCP? The second part to the question, if UDP, how is delivery guaranteed?
Okay, for 61850, for the MMS parts of the client server communication, we are using TCP/IP beyond. Yes, that's correct. So it's the MMS, the manufacturing message system, that is on top of TCP/IP and then on Ethernet. So there we are using TCP. For GOOSE, we are directly using Ethernet communication. So it's more or less using specific Ether types. So we are not using neither IP nor UDP there. There is a mechanism like a routable GOOSE where we will use UDP. But for GOOSE, the delivery mechanism, the delivery guarantee is provided by the repetition, as we have explained. But yes, for the virtual communication, which is MMS based, the TCP/IP guarantees the delivery. I hope that did answer the question.
Okay, thanks, Christoph. Since we are a little tight on time, I'm going to go ahead and hand it over to Jackson to start his part of the webinar. Jackson, I'm going to make you presenter now.
All right.
Okay, you should have the screen.
All right. I just want to make sure you can see my correct screen. Oops. There we go. All right, sorry about that. All right, so thank you, Beth, for the introduction, and thank you, Christoph, for your presentation outlining some of the similarities and differences between DNP3 and 61850, as well as just kind of a basic overview of what the two protocols are. So now moving into the second part of our webinar, we'll actually be doing a kind of a live demonstration using a couple of our different tools. So the first tool that you see up on my screen now is DTM, or Distributed Test Manager. DTM is our flagship multi-protocol test and simulation tool. And today I'm going to be using it to simulate devices in two different protocols, DNP3 and 61850, that you see over here on the left in our workspace tree. Now to create these, this DNP master that you see up here at the top and the DNP outstation that you see right here below, I just right click, manage, add, and then you can see the different protocols that are supported in the tool, which include DNP3, ICCP, 6870, 101, and 104, as well as 61850 and Modbus. So I went ahead and did this at a time. I created, as I mentioned, a DNP outstation and master, and that's what you see out over here on the right, the data map for a DNP3 outstation. As Christoph mentioned, a DNP3 data map is made up of a couple different parts. So first, we're going to have our data type. In this case, I have some binary inputs, double bit inputs, binary output statuses, as well as analog inputs. In the next column over, you'll see the index. So the index combined with the data type make up the address of an individual data point. And at that address, we'll find a value, a quality, and a timestamp. Value being the payload, and then quality and timestamp being associated as metadata with that payload. And then finally, the last part of a data map is the ever important description. And this is what we use as humans to know what this data point actually does. In this case, I've made descriptions and data points that might be used in a bay controller that you might find in a substation, controlling maybe a breaker and two switches. In that vein, I've named this first point enable open breaker QA1. So for a breaker with the name of QA1, this would enable the open. That might be part of an interlocking scheme. And below that, an enable close. Down below in my double bits, I have the positions. So again, double bits, these could be on, off, intermediate, or indeterminate. And then operates to actually open these breakers. And then finally down here at the bottom, I've created a couple analog inputs that might be my phase voltages or currents. Now, the last thing I want to point out before we take a look over at a DNP3 master is class. So as Christoph mentioned, DNP3 has the option to make classes for, or to assign data to different classes. So let me expand out my DNP outstation and just edit that database. And you can see I've done this ahead of time, but I went ahead and assigned my analog inputs up here at the top to be part of class 2, whereas my binary inputs and other objects I assigned to be class 1. And again, that's visible over here on the pane in the right. Again, these are just different buckets or categories that I can assign my data to. But in order to see how that's really useful, I'll need to swap over to my DNP3 master. All right, the first thing you'll notice is that it looks pretty much the same, and that is by design. Your database that exists on your DNP3 outstation is going to match that one that is on your master. But the way that you create these two databases is fairly different. So first I'm going to drag them down side by side so that you can see them next to each other. So on an outstation, to create this data map, it's either done by the manufacturer or vendor when the device is made and then provided to the customer in the form of maybe a PDF or XML DNP device profile or possibly a spreadsheet. But it essentially just is what it is. It's on the device. On some devices, you might have a user configurable DNP3 map, in which case it's up to the user to provide that documentation to whoever's going to be configuring the master. On the master, we must take that documentation, be it a PDF, Excel sheet, or even a DNP XML device profile, which is the machine readable method, and then import that or create the corresponding points on the master. And I've gone ahead and done that ahead of time. So now I've got kind of a mirror of the database, one that exists on my outstation and one that exists on my master. But if I change a value, let's say I change this binary input from off to on, I don't see that change reflected in my master. Which brings me to the next step in our presentation, which is talking about the different tools that we have in our our DNP3 toolbox to transfer data from an outstation to a master. So the first of these is the integrity data poll. So an integrity data poll is initiated by the master and it's a request that goes out to the outstation and says, give me everything you have. So every data point, every value, every quality, and every timestamp for every data point in the database will be sent. This is considered a fairly heavy weight on the wire request because, as I mentioned, everything is sent. But I'll go ahead and just execute that command. And as I do, sure enough, I see that my binary input up here at the top on my master has updated. It went out, it sent a request to my outstation for all data, and then all data was sent back. If we had a little bit more time today, we could look at this in a protocol analyzer and see that not just this was included, but values, quality, and timestamp for every other data point was included as well. And this actually brings me to our next tool in our DNP3 toolbox, which is RBE, or Report by Exception. So this is still a data poll, and by that I mean it is still initiated by the master, but in this case, the master asks for only data that has changed. So since the last time a data poll occurred. Additionally, you can specify what class you want that for. As I mentioned earlier, classes are 3 different buckets or groups that we can assign our data to. In this case, I've configured this report by exception data poll to only ask for data that's part of class 2 events. And as I mentioned, I assign my analog inputs down here at the bottom, which contain my voltages and currents, to class 2. So I'll just put in some values here. And then I'll change this top one back to off and this one below it back to on. Now, as I execute this report by exception data poll on my master, it'll go out, ask for only the changes to class 2. What that means is we'll see the update to the analog inputs over here on my master, but I will not see the updates that I made to my binary inputs as they're part of class 1. So I'll go ahead and execute that command. And sure enough, I can see over here my analog inputs came through, the 1, 1, 2, 2, and 3, 3 that I typed in on my outstation, whereas my binary inputs have not yet changed. And finally, the last DNP3 tool in our toolbox that I want to talk about is unsolicited messages. So unsolicited messages, as opposed to the 2 polling events that we talked about earlier, integrity and report by exception, unsolicited are initiated by the outstation. So once enabled, the outstation will send events automatically up to the master as they occur. In this case, I've set a 5-second buffer window and that will begin counting down as the first event occurs. So once I make a change, let's say I change this binary input to 1, it will begin a 5-second countdown, and any other changes that I make within that 5-second window will be packaged up as the timer expires and sent up to the master. So this is adjustable and can be configured by the user, but the idea is that it's a little bit less traffic on the wire, it's a little bit more lightweight, and you can package things together in that method. So I'll go ahead and enable unsolicited messages. Immediately we see that the changes that I made before to my binary inputs have already come through. And then I'll just go ahead and make some more changes. So let's say, and if I do this quick within that 5-second window, then we'll see they all 3 come in together as they update. And again, unsolicited, I can just do this up at the top and change these guys. And then in just a moment, we'll see, sure enough, a message was sent from my outstation up to my master reflecting those events or changes which occurred. With that, I'm going to go ahead and switch over to 61850 and point out some of the similarities and differences that we see there. So, as Christoph mentioned, 61850 is kind of 3 communication protocols rolled into one, as well as a whole engineering process, which will be the topic of our next webinar. And at the center of these 3 different communication protocols and engineering process is the data model, which is what we see here. Right now, it's just 1 row, and that's because the 61850 data model is hierarchical. It's one of the signature features of the protocol. So at this top level, we see where it says Bay Controller 1. So this is my physical device, or IED. As I expand that out, I see 3 different logical devices at the next tier. So if we could imagine a protective relay that you might have in a substation, that is represented by this top rung or trunk, but as we go down, the first three branches are the logical devices in that. And in this case, they've been used to break up the different functions logically that this device might perform. So those would be control, measurement, and protection. As I expand out one of these logical devices, I'll see different logical nodes. So this is what Christoph mentioned earlier in his presentation. These logical nodes are different data objects or collections of data objects that are associated with different functions. For example, QA1 XCBR. If you're not familiar with 61850, this might look like alphabet soup, but once you get to know the protocol, it becomes second nature. So QA1, that might sound familiar because that's what we named our breaker. And then XCBR, X indicates interface in 61850 parlance, and then CBR stands for circuit breaker. So this is our interface to circuit breaker with the name of QA1. Contained within that are several data objects. The one that I want to highlight is pause, which is short for position. And as I expand that out, I can see an ST val. So this, as a double bit, has 4 possible states: intermediate, off, on, and bad. So this is, if this is sounding familiar, I want to drop down our DNP3 device that we looked at earlier. This is roughly analogous to our breaker position QA1 that we saw in DNP3. But instead of having this flat data map, we have it in this hierarchical predefined data model. So while that breaker position corresponds to that position ST val, I do want to point out that our analog values would also be contained in here. If I navigate down to my measurement logical device and open up my MMXU or measurement logical node, I'll see that I have phase, voltage, and amperage. If I expand these out, I can see phase A, B, and C for both current and voltage. And again, expanding that out a couple times, eventually I can get all the way down to the magnitude of my phase A current. So this value would be equivalent to my phase A current they had over here in my DNP3 map. Now, one thing that I do want to point out before we move on, we talked about in DNP3 how metadata is associated with a payload. Effectively, this on value that we have for the binary input has a quality and timestamp that are associated with it. As Christoph mentioned, things are a little bit different in 61850. If I go back to that position value that we looked at earlier for our breaker, we'll see that we have an ST val, and then below it we have a Q, which stands for quality, and then a T, which is our timestamp. Now, from a data object level, which is what we have here at position, these three are all three together. But I could address just one of these data attributes, for example, the pause.stval or the position of the breaker individually, and send that or read that in a message and not necessarily receive the quality and a timestamp. A small distinction, but we'll see where that comes into play here in just a moment. Now, before I go over to my 61850 client, I do want to point out how we're going to categorize our data that's going to be sent. So for DNP3, we had classes, and we had a limit of 3 classes that we could place our data into. For 61850, the equivalent concept might be called report control blocks or GOOSE control blocks, as Christoph mentioned. So to show those, I'll expand out my logical node LLN0, and then we'll open up the report control section. Within that, I see BRCB stat, so that's buffered report control block stat, and mesh for measurement. And these names are ones that we gave just to kind of categorize what or clarify what sort of data is in that report control block. Within that report control block is a data set. Again, you can have as many data sets as you want and as many report control blocks as you want, the only limiting factor being the device that you're actually working with. There's no limit per the standard. But as I locate that data set, I can see the different data objects in this case that have been placed within that data set. Roughly equivalent to assigning all of these things to maybe class 1, although again, you could have as many data sets as you wanted. And in just a moment, we'll get to see what this report looks like in action. But for now, just know that if any of these items changed per the trigger options that we have set, then it would cause a report to be sent out to a client. In much the same way, we have our GOOSE control blocks seen up here, which have data sets as well. And as I locate those data sets, I can see the data attributes which make up my data set of my GOOSE control block. As we started out by saying, there's really 3 protocols in one that make up 61850, and these are 2 of them. The first being report control blocks that we looked at a moment ago, and the second being GOOSE. But to see these in action, I'll need to open up a 61850 client. So let me go ahead and do that. And I'll drag that down just so we can see it side by side. So just like in DNP3, where we see kind of a mirror image between our master and outstation, we see the same mirror image in our 61850 client and our 61850 server. So the client over here on the right has the same data model as I have configured it for my server. In this case, instead of using a spreadsheet or a PDF, I did use the SCL file or system configuration language in order to create my client. And we'll talk a little bit more about SCL during our next webinar on 61850 engineering process. But as I expand down my control logical node into my XCBR and take a look at that same position value, and I'll pull it up on my server as well, I want to show that if I make a change on my server, by default, it will not come through up to my client. Even though we saw that this position value was part of a data set that was part of a report control block, I must first enable that report control block in order to receive the value. I could do a one-time read just by right-click and hit read, but if I want to receive that value automatically, maybe kind of similar to unsolicited messages that we saw in DNP3, then I would come up here to my LLN0, expand the report control block section, and then just right-click and enable the report control block. So now I've enabled it, I've reserved it for myself as a client, and anytime any of those values change that are in the data set associated with this report control block, I'll see it over here on my server. I'm sorry, on my client. Expanding back out to that position value. Now, if I make a change on my server, I can just change it back to on, and immediately we'll see that change reflected up here on my client. So as I mentioned at the beginning, we're going to be looking at 2 tools. Next, I'm going to be pulling up Test Suite Pro, and that's so that we can take a closer look at what's happening under the hood in these report control blocks. And then after that, we'll take a look at another one of the protocols that makes up 61850, and that's GOOSE messaging. And Test Suite Pro is what you see up on my screen now. So while DTM is multi-protocol and focused on simulation, Test Suite Pro is more of a testing focus, visualization and analysis of protocols, and it's specific to 61850. So on this first system status screen, you'll see where I've connected to that 61850 device, that Bay controller. And let me just pull DTM over here. As I move down into the advanced client, we'll see a very similar view to what we saw in DTM. These are the 3 different logical devices which make up my IED. And then as I drill down further, I can see the different logical nodes that are contained within it. If I wanted to, I could go ahead and execute a read on maybe this position value, but that's really not the magic of 61850. It's really in the report control blocks. So I want to enable this first report control block. Before I do that, I need to disable it in DTM on the other client that I have. So bear with me as I do that. All right, now I can enable it over here. And if I come back down to my XCBR position value that I looked at before, currently set to on. Now I'm making changes off screen over in DTM, but I'm just going to change that value from on to off. And just like we saw before, it's going to come through here into my test tool. But as I promised, I want to take a little bit closer look at what's actually coming across the wire. In order to do that, I'll be using one of the tools within Test Suite Pro named Report Viewer. So let me start out by beginning a capture, and then I'll go ahead and make a change again over in DTM off screen, and that will trigger a report to be sent, which we see here on the right. So this is a report that just came in, and the first thing I want to point out is the reason for the report. It's a data change, and we'll take a closer look in a minute at what the different reasons or options are for why a report could be sent. But in this case, it's because a value changed, and it was the on value or off changing to on for the breaker position. I'll go ahead and issue a second change by changing that breaker back to off or open, and we'll see that a second message comes in. I can select both of them, and it'll highlight the changes that occurred. In this case, it was the breaker changing from on to off, and then the timestamp updated as well. Now, one thing that I want to point out is that in this data change event for an MMS report, only the data object which changed is sent across the wire, not all of the data that makes up the data set. However, there are other methods or triggers that you can have for a MMS report. For example, if I expand out my trigger options field on my report, we'll see that I have integrity poll. Now, integrity poll, the name sounds familiar, we spoke about it earlier for DNP3. Integrity poll requests all data on DNP3 and requests the data at periodic intervals. It's typically sent from the master to the outstation. Similar in 61850, although instead of being a request from a client to a server, it's actually configured on the server, and then the server will periodically send that data out. But just like an integrity poll in DNP3 in 61850, all data in the data set will be sent at that interval, not just the data that's changed. So I have that trigger option set up, and then down here I see this INTGPD, that stands for integrity period, and so I'll set that to 10,000. This is a milliseconds value, so 10,000 will represent 10 seconds, and then I'll go ahead and enable that report. Immediately we'll see integrity data polls begin to come into our report viewer, and as I click them, you'll notice that there's a lot more data present. This is because, as I mentioned, an integrity poll sends all data every time it is initiated. And finally, before I turn it back over to Beth for Q&A, I want to take a look at GOOSE messaging. So I know we keep harping on it, but I think of 61850 as 3 protocols in one. The first one that we just looked at being report control blocks, and the second one being GOOSE messaging. So much like report control blocks, GOOSE messages rely on data sets, as I mentioned. And if I locate the data set for this report control block, for this GOOSE control block, I can see that the same breaker position value is contained in the data set. This means that if I make a change to this value and I've subscribed to this GOOSE control block, then I'll receive that message, and I'll receive it very quickly. To reiterate what Christoph said earlier, and one of the questions that we received during the break, GOOSE is the high-speed messaging system that's meant to replace wires, and it typically goes from server to server, whereas MMS or report control blocks is still speedy, but not as fast, not in the millisecond range, and is typically used for vertical communications, which go from a server or IED, say a protective relay, up to a SCADA system. And with that, I'm going to go ahead and subscribe to this GOOSE control block, and then I'll switch over to my GOOSE viewer tool in the pane over to the right and click start to begin recording. So as Christoph mentioned, there's a sequence number and state number. The state number increments every time something in that data set changes, and then sequence number refers to the number of retransmissions that occur. So this is the initial retransmission that I captured when I began recording, and I can see the current values of all of the data attributes within my GOOSE control block. But if I come back over off screen to DTM and change that value from off back to on, immediately I'll see a new GOOSE message come in with a reset sequence number back to 0, indicating that this is not a retransmission, but an original transmission. And then the state number will increment as well as a result of the change of the value. And if I highlight these two messages and then scroll over to the right, I can see that highlighted in our tool is what changed between the two. And that's going to be this position value that I just swapped over in DTM. And with that, I think we're running out of time. So I'm going to go ahead and turn it back over to Beth, who's going to handle our Q&A session. Thank you.
Thanks, Jackson. Yes, we are coming up to the hour. So I think what I'd like to do is I'm going to take the screen back from you and just go over some final points. And then we can switch over to the remainder of the Q&A. As I mentioned earlier, anyone that would like to stay on longer, we're happy to stay on and continue to answer questions. So please feel free to continue to submit them. With that, just to wrap up, so the webinar will be posted to our website, trianglemicroworks.com, in a couple of days. You'll see it right there on the homepage. A follow-up email will also be sent out that will include a link to this recording. And when you do leave the webinar, you will be prompted to answer a survey. It's only about 5 questions, takes about 2 minutes. We really appreciate any feedback that you have on what you've seen here today. And really any thoughts. You can even continue to submit questions via that survey, and we will respond to those. We mentioned that this is a 3-part series. Today was part 1. Part 2 is IEC 62050 SCL in the engineering process. That will be hosted on May 4th at 10 a.m. Eastern Time. And then part 3, strategies for integration of DNP3 and IEC 62050. That will be hosted on May 24th at 10 a.m. Eastern Time. So again, you can go to our website under training tabs and get the links to sign up for each one of those webinars today. In fact, I've noticed that a lot of folks that signed up for this one have already signed up for part 2 and part 3. That's great. Get it on your calendar now. If you haven't, please go out there and go ahead and sign up. And then, of course, if you have any questions, you can always just email sales@trianglemicroworks.com. So with that, I'm going to switch it back over to Q&A. We did have a lot of questions come in the last 15-20 minutes, and a lot of them have already been answered online, but I'll go ahead and just kind of take it from the top for the benefit of the whole audience. So I'll throw this out to you, Christoph. Is slave master the same as client and server?
So the question is for me, should I? I mean,
yeah.
There have different answers being provided. I mean, my short answer was when we talk about DNP3 over Ethernet, we can basically assume a similar mechanism. So in that case, the master outstation that we have in DNP are really comparable to client server that we have in 62050. As a short answer. Master slave is really coming from the time when we had serial links, where there was also a need to have a media access control. So not just every device could start talking, but with an Ethernet network, we don't really need that. So that's why master slave can be compared with client server.
Okay. Christoph, I'm gonna keep the focus on you with this next question as well. I see that a couple of folks did answer this online, but you did as well. As far as I know, IEC 61850 comprises not only protocols, MMS, GOOSE, and sample values, but also common routines for exchanging interface files, ICD, CIDs, etc. Does DNP3 provide similar functionality?
As it has been answered, I don't think, I mean, DNP3 supports the XML device profile, which corresponds to an ICD file in 61850. And we will talk about in the webinar 2 in more details about the engineering process. But in DNP, we don't have behind an engineering process defined like in 62050, where we define system tools that can import this ICD file and use it then to configure the whole system. So that's not available in DNP. But the whole engineering process we'll talk next webinar.
Okay. Next question. There is a mechanism how DNP3 slave devices can get information for other DNP3 devices not hardwired, just like GOOSE devices interchange data. Data. So I guess the question is there a mechanism on how DNP slave devices can get information?
Can I answer, or Jackson? I can answer. I mean, there is no standard mechanisms in DNP3 to exchange directly information between devices. As it has been stated in one of the responses, we have systems where users are using GOOSE together with DNP3 to perform that functionality. In other cases, it's still wired. And we will discuss this a little bit in the webinar 3, the possibility to use GOOSE in parallel with DNP3.
Okay. So next question, I'm not sure if this is for Christoph or Jackson, so either one of you can take this. The databases these programs are using must be different from the one the IEDs contain the binary information. Is that correct?
I'm not sure that I understand totally, but in general, I would say the database that we're using in DTM to represent a device could absolutely be identical to what you have in a physical device. Let's say you had the documentation that defined the database for a real DNP3 device, be that a spreadsheet, a PDF, or a XML device profile. You could create a mirror image of that, or a simulation, a copy, whatever you want to say, in using DTM. It's just a matter of addresses, point types, and then really descriptions are secondary. And there's some other settings parameters that you have access to as well in DTM. I showed class, but there's many others as well.
I think there is a follow-on question on that just popped in.
I did just see that. Yeah, I can go ahead and read that one. What about the way the IEDs store?
No, further down, Beth.
Oh, further down?
Anyway, my actual question is.
Okay. My actual question is, how would you carry out an integration of the IEC 62050 protocol between two substations, one more modern with the protocol already integrated between relays and PLCs, and one a bit older using less older methods of communication and control?
So that's actually a large topic of webinar 3. Christoph, if you have more to add, then please do. But there's certainly methods of upgrading your existing substation to 61850 or integrating in a substation which uses older protocols, for example, DNP3 or 101, 104, something like that. You could use data concentrators, or you could use some of the engineering processes that we'll be talking about during webinar number 3. Christoph, do you have anything to add on to that?
Yeah, and I'm depending on how to understand the question. I mean, let's assume one substation has still, as he says, less modern methods of communication. Yeah, you could have a gateway somewhere that goes from the whatever communication you have to 61850. And then it's yeah.
We do provide a SCADA data gateway. You can see more information about that on our website, but that does convert between all of these different protocols that we've been discussing today and many more.
Okay, thanks. Next question. What is the motivation behind IEC 62050 and how it is enabling a digital substation in a way DNP3 cannot? Probably give that one to you, Christoph.
Well, I think one of the key elements is, like it has been answered already, the engineering process that we will discuss in the next webinar. That's one key feature, and the other features that really make it, well, it always depends what you call a digital substation, but commonly we understand the digital substations where we have merging units that do the directly the analog to digital conversion, and again for that we have the sampled value service. That is something that we cannot directly use in DNP, but in principle, as we mentioned before, you could do a combination of using DNP3 with GOOSE and sampled values, and that would probably also allow you to build a digital substation. But I think the key differentiator is really also the engineering part that we will discuss in webinar 2.
Okay, next question. Can I select more than one data attribute on one data point in 61850?
The short answer is yes. There are communication services that we didn't enter in all the details, but we have a classification of data attributes as with function constraints, like function constraints for status attributes, for configuration attributes. And one way to access more than one data attribute is that I can select access all the attributes of function constraint ST as an example, status information from a data object position. I have this possibility. I can also, from an addressing perspective, select even multiple data points, multiple data objects by addressing the logical node.
Okay, next question. Christoph, this one I think is for you. What's the most used for integration nowadays, DNP3 or IEC 61850 in substations?
Sorry, can you repeat it?
Sure. What is most used for integration these days, DNP3 or 61850 in substations?
Well, it depends a little bit on the areas. In some countries, they are using almost only 61850. I mean, in Europe, in many places, okay, we anyway didn't use DNP3 in Europe. There was the corresponding thing, 6875, 101, 104. That was very popular. But in many countries, the utilities are now completely applying 61850 there. In North America, DNP is still much more used, but 61850 usage is growing, and mainly in the context of digital substations, where they include as well sampled values and these communications.
Okay, next question. And Jackson, you've already touched on this, so maybe this will just reiterate some of the points you already mentioned. You can take this one. Is it possible to convert protocols between DNP3 and 61850?
Yes, absolutely. There are several different ways to do that. You can, using a DNP XML device profile, define those mappings. We'll be talking a little bit about that during webinar 3, but you could also just simply do it in a gateway or protocol converter, such as our SCADA data gateway. And you would need an ICD file, an SCL file, which describes your 61850 device. But the answer is yes, absolutely. And you can do that in both directions, from DNP3 to 61850 or vice versa.
Thanks. Okay, next question. Christoph, I believe this one is for you. For MMS part, how many subscribers can connect with the publisher at one time?
Unlimited subscribers can receive the message from the publisher.
For MMS, it's a one-to-one.
Okay. Sorry, I missed the first part of the question because I was typing in an answer to another question. So MMS is not publisher subscriber. MMS is client server, and there is always an association between one client and one server. Yes.
But you could create multiple report control blocks which share the same data set, in which case you could have multiple. I suppose the limit is defined by the specific device that you're working with, in terms of the number of report control blocks that it would support.
Okay. Well, I think we have covered most of the questions, if they have not already been answered online. So with that, I want to thank everyone for spending the time with us today. Again, I encourage everyone to go to our website under the training tab and sign up for part 2 and part 3 to get those on your calendar. And I appreciate you staying on even longer, past the hour, so we can wrap up with the Q&A. Once you sign off here, you'll get prompted with the survey. I reiterate, appreciate if you can fill that out and give us your feedback, and we look forward to seeing you next time. Thank you, everyone.